Section 10.6. So the video didn't work very well last time we tried this. So let's try it again. I'll just go through this pretty quickly. Since we taught it yesterday, I'll just go through it rather quick. Let's do this. First thing we did was what? Oops. Let's change this to a line. Let's change this to a line. Right. Were you listening to what I just said?
Kinda.
Oh, my mistake. Right. I gotcha. Yes, you're right. I did do that yesterday. All right. So what are these? These are two what? They're two secants. Well, they are chords technically, but we're going to call them secants. They keep going in both directions. Okay. So if you have two secants, then they intersect where? That's the important part of this. They intersect inside the circle.
Boys middle school baseball at this time. Thank you.
Secants.
Also,
S.
at 1:45, if you could dismiss girls varsity softball. Thank you.
Where are you going? It's not 1:45.
She got up and
All right, so let's do this. Let's say we'll call this angle 1. Is that all right?
No.
And we'll call this A, B. We'll call this C, D. All right, so look what we have. We talked about this. I'm not going to mark these things.
Is there any homework?
There is. You have to check the thing. All right. I don't know. It's on my desk. I sent you an email this week. Nobody reads my emails. All right, so here we go. Watch. Angle 1. What does angle 1 equal? Angle 1, this angle right here, equals half what?
Isn't it?
It doesn't equal the arc, okay, because we don't know that's a central angle, do we? If it was a central angle, then that angle would equal arc AB.
Half of AB plus CD.
Right. It's half of the two arcs, okay, that's formed by those two secants, okay, the subtended, as Khan would say. All right, so it's 1/2 of arc AB, what? Plus, right? That's the big difference between this. It's plus arc CD. All right, so that's what that thing says. Now, if you did this, let's put a 2 right there. So what would angle 2 be equal to? It's half of what? What would angle 2 be equal to? Arc AC. Half of arc AC plus arc BD. All right? Everybody got that? Talked about that yesterday. We even threw some numbers in yesterday. But my video didn't work for some reason. Didn't like it. So, but that's the first thing we did. No, I will.
Are we learning 10 seconds?
We are. Okay, so that's the first thing we learned yesterday. Everybody's got that? All right, then we had two secants that intersected outside. Is that what we did? Is that the next thing in your notes? I think so. I don't think they go in that order. They don't go in that order in the book. They don't do that order in the book, but we'll do that order, okay? So let's do this. Let's draw our secants a different color. Let's actually move this over, make it just a tad smaller. Just give myself some room. Yellow, okay. It's a beautiful yellow. I picked Global Pure Yellow. You can't get any more yellow than that. That's what they call it. Look, if I had... Yes, Jocelyn. Yes, take a pass. All right, let's take everybody look up here. Come on now. Let's pay attention. If you have a point outside a circle, and if you draw two secants, so there's a secant right here, and there's a secant right here. Let's mark some of these points again so we can talk about them. So A, B, C, D. And we'll call it angle 1 again. Is that all right? So this angle right here is angle 1. Now we learned something when the secants intersect outside the circle. And they form that angle, don't they? Okay, they form an angle. And so that angle right here, this outside angle, is equal to what? It's still half of, right, the two arcs that it intersects, right? This one right here and this one right here. It forms those two. And so it would be AD minus this time. When it intersects outside the circle, it's subtraction. And it does matter which order you subtract it in, doesn't it? You take the larger arc, which is the one that's furthest away, and then minus the smaller arc, and that's the one that's a little bit closer to the angle. So make sure that you subtract them in the right order. You don't want to get any negative angles up here, all right? So if you get a negative angle, you know you did it wrong, all right? So that's what we talked about yesterday. And then we did a second thing, didn't we? Third thing. We just did the second thing. Thank you. Let's do the third thing. What do we have? Didn't we have a tangent? Didn't we have a tangent and a secant? Yep, this was right at the end of the class. Okay, so here's a tangent, so I'm going to scooch it up until it hits right there. All right, so that would be a tangent. That's the point of tangency where it hits the circle. And then we're going to take, from that point of tangency, we're going to draw a secant. Just draw it out like this. All right? And again, let's call that A, call that B, and we'll give a point over here so we can talk about this major arc right here, because we'll have to talk about the major arc. All right, let's take a look at these two angles. Let's look at this angle right here. We'll call that angle 1 right there. Everybody got that one? All right, we could have just labeled the angle, but I'll just call it angle 1. This is actually pretty easy. Angle 1, we don't have to do the difference or the sum of anything because angle 1 is just half of the arc that that angle creates, right? Or it cuts off. It cuts off that arc, what? BA. Everybody see that? Or AB. What do you want to call it? Let's call it AB. That's all you have to do. You just take half of it. So if that arc was 50 degrees, what's angle 1? 25 degrees, okay? That's all there is to it. Everybody got that? And when does that happen? It's when a tangent and a secant intersect, and the only way that they can intersect is, well, I shouldn't say that. If they intersect on the circle itself. So if they intersect on the circle itself, then it would intersect at the point of tangency. Got it? Okay. Let's call this angle right here, let's call that angle 2. So what would angle 2 be equal to? Well, it would be half of the arc that it cuts off. See this angle right here? It hits right here, and it hits right here. So what angle is it? ACB. Good, let's call it that. Let's call it arc ACB. So this big old major arc, that's why we use 3 letters, isn't it? Because it's a major arc. It's more than 180 degrees. So we use this whole big major arc right here, and this angle is half of that big old arc. They should. Yep, 1 and 2 should equal 180. And so those 2 arcs should equal 360, twice as much as the 180, right? So it kind of makes sense, doesn't it? That it's half of those arcs. Okay. All right, that's the last thing we talked about yesterday. So let's continue. We'll keep our same color scheme here. Yes. You got 1 minute. Missing out on all this fun stuff. What if we had a secant and a tangent again, but this time they don't meet at that point of tangency. They don't intersect at the point of tangency. Let's say you had, let's say they intersect outside the circle, okay? So there's a tangent, and let's say a secant, and they intersect outside the circle. Let's say at that point right there. Everybody see that? So let's talk about this angle. Let's use a different number. I've been using angle 1. Let's just say angle 3. Is that all right? Just to be different. Now look, it hits right here, hits right here, and right here. So let's use A, B, and C. I'm not being different on those, but that's okay. All right. And so what do you think is going to happen right here? This angle, look what it does. It's not just half of this arc because it cuts off 2 arcs, doesn't it? But both of those arcs kind of end up at C, don't they? The arc AC ends up right here, and arc BC ends right here. It's kind of the same thing as if you had 2 secants. So angle 3 would equal what? Half. Now this intersects outside the circle, so what do you think we're going to do to those 2 arcs? We're going to subtract them. No, outside we subtract. Only when they intersect inside do you add them up. And so what are our arcs here? We'll just call it BC. That still looks like a minor arc, doesn't it? So BC, what? Minus AC. You with me on that? So we have a secant and a tangent, just like we had before, but this time they don't intersect on the circle, they intersect outside the circle. When they intersected on the circle, it was just half of the arc. This time it's half of the difference of the 2 arcs that it cuts off, right? Everybody see that arc, right? This one right here and this one right there. All right, softball, if you have to go. Where are you going, to Polytech today? Delcastle. I thought somebody, oh.
Polytech is like, actually like
Lacrosse is Polytech, right? And soccer. That's right. All right. Oh, let's do this. What if we had two tangents to a circle and they meet outside the circle? I don't think we've done that, have we? So let's do that. Let's have two tangents that meet outside the circle. So here's a tangent right there, and here's another tangent right there. Thank you. All right, let's say those tangents meet there. And we'll give this some letters. We'll just call this A. Yeah, they're tangents because they just meet they just hit the circle at one point. All right? And again, we'll give this a number. Let's call this angle 7. All right? I don't know why. Just wanted to use angle 7. All right? So angle 7. What do you think here? They intersect outside the circle, even though it's two tangents. It's not two secants. It's not one secant and one tangent. It's actually two tangents. They meet outside the circle. That's really important, okay? Because the same thing holds true almost every single time, doesn't it? When they intersect outside the circle. It's going to be what? It's going to be half. Now, what arcs are cut off here? Let's stick another letter in here. Is that all right? Let's put a D. Yeah, let's put a D right there. All right, Caitlin, what do you think?
Is it the arc where the two tangents meet, so BC, is it BC minus angle A?
Now, the angle A, which is angle 7. Right. Do you want to call it angle A instead of 7?
Yeah.
Would that be better? Okay, so you don't get confused. So angle A is equal to what? Half of.
BC minus BDC.
You sure you want to go that way? Because yeah, that's what I would do, because BDC is a major arc. So I'd do the bigger one minus the smaller one. But you're exactly right. So it's BDC minus what? BC. And that's... Am I off the screen? Okay. All right. Does that make sense? Okay, so what if they just told you, what if they said that this was, I don't know, 120 degrees? So arc BC was 120 degrees. That's the only thing that they told you. Could you find angle A? Yeah, you got to subtract the two arcs. Problem is, I don't know BDC. Yes, you got it. So what's 360 minus 120? It's 240. So you had to figure that out, though, right? So that big old arc BDC is 240 degrees. Yeah, 240 minus 120 is 120 again. Take half of it, and that's what? That's 60. Got it? Yeah, but I just did it right there. Okay. And actually, I should have done this if I wanted to show some more work. I would have gone 240 minus 120 over 2, and that's 120 over 2, which is 60. Okay? So yeah, you can definitely show work on that. But but you need to get used to showing your work, because it might be annoying now when you can do stuff in your head, but the more you get used to showing your work and showing all your steps, when you get to stuff that's really complicated, and this stuff's not complicated at all, but when you really get to stuff in your math career that's very complicated, you're going to be glad that you're one of those students that always showed all their steps. Because the people that get in trouble, I'm telling you, I know this from experience by teaching these kids. I mean, I've taught some kids that are just brilliant kids and could do so much stuff in their head, but then they get the things that are really, really tough. You start getting a pre-calc or calculus and things like that. They used to be able to get away with doing things in their head, but you can't do that when you get up into calculus. There's so many different steps that you have to do. There's no way that you can do a lot of that. Now, some of the stuff you can, but some of the stuff, there's no way. You've got to show your steps. And I think it's what I'm trying to do is just, I'm trying to make you do this to prepare you for the future. I'm trying to prepare you for the classes that are a lot tougher, okay? And I want you to have that experience of showing your work all the time. It's the people that don't show their work all the time and that are, are bright kids, and they get up to a class that's a little bit tougher, and then they struggle a little bit when I don't think they should, they didn't need to struggle, okay? It doesn't mean you can't succeed if you don't show your work now, but it would really, really help you in the end. I think we covered everything on that lesson. Yes, we did. I didn't really give you too many examples except for that one at the end, but you get the idea of what we're going to do. All right, so that was section 10.6, right? So I'm going to make two different videos, okay? I'm going to make 10.6 and 10.7.